Welcome to Study Loop.
Okay, this question is about histidine, which I will sketch in the general case here. The neutral, completely unionized histidine, right? So we have our carboxylic acid, our alpha carbon. Coming off of our alpha carbon is our primary amine. And coming off the alpha carbon also is our side chain, right? And then coming off of our side chain is our 5-membered ring. With a couple of nitrogens, like so. Okay, so this has an overall charge of 0. And the idea is that at various pKa, or various pHs, the following functional groups will become either deprotonated or protonated depending on the pH presented, right? So we know that this carboxylic acid has a labile proton, that is, it becomes deprotonated at relatively low pHs, and especially at higher pHs, right? That our primary amine is fairly basic and becomes protonated at relatively high pHs, right? It's rather easy to protonate this primary amine, and that our next most basic nitrogen is the one here, and that our least basic nitrogen, which in effect will not change throughout the course of the changing of the pHs, is our secondary amine here. Okay, so we've established then the following. This is acidic. This is most basic. And this is, let's call it least basic. And let's call this not basic for the purposes of this problem. Okay, so let's say we jack the pH all the way up, right? We're going to jack the pH very high, right? Such that we'll deprotonate anything we can, except for, our amines, which really cannot be deprotonated at any sort of reasonable pHs, right? These have pKa's of somewhere around 40, right? So effectively what we're going to do is deprotonate our carboxylic acid at pH 12, right? So here's the sketch at pH 12. Our carboxylic acid becomes deprotonated. But the remainder of our structures will stay neutral, right? Our amines will not be protonated or deprotonated at this step. Now, if we continue on and lower the pH, right? So slightly less basic, but still on the basic side of pH 7, right? We will begin to protonate our most basic amines, specifically our primary amine. I'll note here that the overall charge of this molecule is -1, and that as we lower the pH, O minus, this will remain charged. We will protonate our most basic amine. Like so. And that the overall charge here will now be 0, and we'll continue on to pH 4. Right? Carboxylic acid will still be deprotonated, right? It's fairly acidic. Even at pH 4, it's going to be negatively charged. Our most basic amine will still be protonated, right? We're getting more acidic. There's no reason for it to become less protonated. But now we will find that our next most basic amine that is the one with the lone pair here will become protonated and positively charged, like so. And that at pH 1, oh, and note that the overall charge here is +1. And that at pH 1, the final difference will be protonation finally of our carboxylic acid, OH. The amines at this point, or ammonium ions, will remain unchanged. We'll have 2 protonated amines, like so. And our secondary amine will never become protonated at these pHs. And the overall charge here will be +2. So at each stop, our charge increases as the acidity increases. And we get subsequent protonations of, at each step, the next most basic functional group, starting with our least basic functional group, the carboxylate, followed by the next most, followed by the primary amine, and eventually the nitrogen with the lone pair, and then eventually protonation of our carboxylate.